In this video, we're going to go ahead and look at this problem, how to solve this. So we have the average credit card debt carried by undergraduates is normally distributed with a mean of 3,173 and a standard deviation of 1,120. A certain college wishes to help their students stay out of credit card debt and launches a program that teaches their students the danger of high credit card debt. After the program, they ask a simple random sample, or SRS, of 25 undergraduate students how much debt they have and find that the average is 2,700. Does this indicate that the program worked and why? So we're going to see if this new program, if it looks like it worked in lowering our credit card debt from $3,173 to $2,700. Or could this number be lowered just because of random chance? So our first step is, and we'll go look at this flowchart, is it a means or proportion problem? So if we look here, it says right here mean, so that makes it a means problem. So we go follow our flowchart down to here. So our next step is to calculate the mean and standard deviation of our sampling distribution. So to find the mean, or the average, of our sampling distribution, that just equals the mean of our population, which is 3,173, this number right here. So the mean of our sampling distribution is $3,173. Alright, so then we go to our standard deviation of our sampling distribution, and that equals the population standard deviation divided by the square root of n, and n is the number of people that we asked. So we go here. So our standard deviation of our sampling distribution is the standard deviation of our population, which is 1,120. So we take the 1,120 and divide it by the square root of n, which is 25, because that's how many undergraduate students we asked in our sample. And so then we go pull up our calculator, and we take 1,120, divide it by the square root of n, which is 25, and that gives us 224. So our standard deviation of our sampling distribution is 225. Now if you remember, we're checking to see if it's normal, which we'll actually go ahead and check first. We'll go look at our flowchart. So we calculated the mean and standard deviation, so we follow this arrow down to now we check the central limit theorem. So we have two things to check. Is the population normally distributed? So we'll go look here, and it says right here that the average credit card debt carried by undergraduates is normally distributed. Because the population is normally distributed, so this one works, the central limit theorem. The population is normally distributed. Let's go ahead and check the other one. Is n greater than or equal to 30? And in this case, it's not. N is only 25. But because it's an or, we need one of these to be true. And the population is normally distributed, so we can use the normal approximation. So we can calculate our probability using our normal CDF in the calculator. Again, if the central limit theorem does not hold true, then we can't calculate the probability using normal CDF. So we'll go ahead and look at this one. So we can draw a normal curve because it's normally approximated. Alright, so it's normally approximated. So we can go ahead and our sampling distribution is normal. And it is centered on our population mean, which is 3,173. Now we're looking at our sample shows only an average of 2,700, which would be down here somewhere. And we're looking at this area. We're trying to find this area because that's the probability of getting this value or less. Because remember, with normal curves, you always do a range of values. And so we want to find what's the probability that we'll get a sample which has an average less than or equal to $2,700. Now to do that, we're going to use our calculator and we're going to do the normal CDF. So we go second, distribution, we go down to normal CDF. Now our lower in this case is going to be some big negative number. It's give us a big negative number by default, so we're good there, because we're looking for everything below this. So you just give it a big negative number. Now the highest value we want, which is upper, that's the 2,700, because again, we don't want anything above that number. Because that's the number we got, and we want to know, could our average actually be that number or less? So we put 2,700 into upper. Our mean, that's the value we calculated up here, 3173, and a standard deviation of 225. 225. So we'll go ahead and hit paste and enter, and we get this value right here. So I'm going to write that down. So it's 0.017. I'm going to round it to 178. Now, so the question is, does it look like this program worked? Now, the probability that the program didn't work, that the number that we got, this 2,700 that we got, was just because of random chance and not because the mean is dropped, is only 1.78%. That's a really low percentage. So for this one, because of that, I would say yes, because the probability the program did not work is only 1.78%. Scroll up, which is low. So we have a low probability. So it looks like this program did actually work, because it looks like we actually dropped our value.